In this video, we're going to be looking at the discriminant. So we'll start off with the introduction and some theory behind the discriminant, and then we'll move on to looking at 4 examples for the remainder of the video. So let's get started. So previously you may have looked at solving quadratic equations using a variety of different methods. One of those would have been the quadratic formula, or hopefully you've seen the general quadratic formula before now, which states that if we have a quadratic equation in the general form ax squared plus bx plus c equals 0, then our solutions are given by negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So examples of using the general quadratic formula show us that it is possible for quadratic equations to have 0, 1 or 2 real solutions. And a reminder that in these videos we're not going to consider the complex solutions that you can have to these sorts of equations. That's beyond the scope of what we're doing. So the discriminant, which is b squared minus 4ac, which is the expression under the square root sign. So that's important because we know that there's certain restrictions on what numbers are allowed under the square root sign. It gives us information about the number of solutions to a quadratic equation. So first of all, if the discriminant is greater than 0, or that is that the discriminant's value is positive, then we get 2 real solutions to that equation. And on a graph, that would be the same as thinking about getting 2 x-intercepts. So the graph that's shown up here, you'd have an x-intercept here, and a second one over here. And this is just one graph. Any graph that cuts the x-axis twice will have a positive value for the discriminant. Next, we consider the case where the discriminant is equal to 0, and that gives us 1 real solution to the equation, which is equivalent of having 1 x-intercept on the graph. So again, a general case is shown here, where we've got our turning point being the x-intercept, and that lies on the x-axis. So any graph whose turning point is on the x-axis will have a discriminant whose value is 0. Finally, if the discriminant is less than 0, so that is you have a negative value, then there are 0 real solutions to that equation, which means on the graph you won't have any x-intercepts. So for the red graph down here, the third graph that's shown, we can see that the parabola never cuts or touches the x-axis. So for any parabola, we could draw another one up here. For any parabola whose graph doesn't cut the x-axis or touch it, it will have a negative value for the discriminant. Furthermore, if the discriminant is a square number, so they are numbers like 0, yes, even 0 is a square number, 1, 4, 9, 16, etc., then we know that the solutions will be rational. If the discriminant is some number other than a square number, then we would get irrational solutions, and they're sometimes referred to as the nature of the solutions. So let's get into some examples. So for the next 4 examples, we want to determine the number of solutions to each of the following equations, and we know that we can now use the discriminant to help us do that. So like when we were solving using the general quadratic formula in a different video, we like to check that it's in the form ax squared plus bx plus c equals 0, which a and b both are, and then we can identify the coefficients of x squared, so that is the a value, so a equals 1, the coefficient of x, which is b, so b in this case equals positive 4, and the constant term c is going to equal 7, for example a. Then we write down the expression for the discriminant, so delta is equal to b squared minus 4 times a times c. So therefore, the discriminant's value for this example is going to equal b squared, which is 4 squared, and we use brackets whenever we substitute in. So we have 4 squared minus 4 times a, which is 1, times c, which is 7. So therefore, the discriminant's value is going to equal 16, so that's 4 squared, minus 4 times 1 times 7 is minus 28. So therefore, the discriminant is going to equal minus 8 for part A. So as the discriminant, so that's delta, is less than 0, that tells us that we get 0 real solutions. So that is the answer to part A of this question. It asks for the number of solutions that we would get to that equation. So we get 0 real solutions. And now we'll move on to part B. So we'll follow the same process of identifying the A value, the coefficient of x squared is 1 in this case. The B value, which is the coefficient of x, which is negative 3. And just be careful to include the sign there. And the c value, which is the constant, is going to be negative 10. And again, make sure that you include that that value is negative 10, not just 10. Then we write down our formula. So the discriminant is equal to b squared minus 4ac. And I'd encourage you to write it down each time so that you substitute incorrectly. So therefore, the discriminant's value for part B is going to equal b squared, which is minus 3 squared minus 4 times 1 times negative 10. So therefore, the value of the discriminant is going to equal negative 3 squared, and just be careful here, it's positive 9. And we need brackets around that negative 3 and then squaring it. And then we have minus 4 times 1 times minus 10 gives positive 40. So you've just got to be really careful to keep track of your negatives in examples and questions like this. So therefore we know that the discriminant is equal to 9 plus 40 is 49. So as the discriminant's value is greater than 0, that means that we get 2 real solutions. So that is the answer to part B of this example. However, we're also going to just touch base on the nature of the solutions. So because delta, the discriminant, is a perfect square, so that is that 49 can be written as 7 squared. So 49, the discriminant's value, is a perfect square. The solutions that we get are rational. And by rational, we mean that it is a non-surd value, essentially, for questions like this. So if you were to plug this into a calculator, or you were to go through and solve this by hand, the solutions, just for interest's sake, would have been x equals minus 2 and x equals 5. So they are considered to be rational numbers, and there's no surds present. So our third example is 4x squared minus 12x plus 9 equals 0, and we still want to determine the number of solutions to that equation. So we start off by working out what our a value is, which is the coefficient of x squared, so a is 4. B, the coefficient of x, is going to be minus 12, and c, which is the constant term, is positive 9. Next, we write out the formula, which is the discriminant is b squared minus 4ac. So therefore, the discriminant for this question is going to equal minus 12 in brackets all squared, minus 4 times a, which is 4, times c, which is 9. So therefore, the discriminant's value is going to equal minus 12 squared is a positive number, and it's 144. And then we subtract off that 4 times 4, which is 16, times 9, which is also 144. So therefore, our discriminant value is going to equal 0. So as the discriminant is equal to 0, that tells us that there is one real solution. So that is the answer to part C of this example. But as with part B, we could go on and explore the nature of this solution. So because the discriminant's value is a perfect square, so that is that the discriminant's value back up here is 0, can be expressed as 0 squared, so it's a perfect square number. The solution we get is going to be rational. And again, by rational, we mean that there's no surd or irrational part to that number. So the number is going to be an integer value or a fraction value. And in this case, if you were to go and find it using a calculator or solving it by hand, the solution would be x is equal to 3 over 2. And that is a rational number, as it's a fraction of 2 integers. So you can see there's no surds present, which means it is rational, so far as we're concerned for quadratic equations. So part D has 2x squared equals negative 8x plus 4, and it has an extra step before we can apply the discriminant. And that is that we need this equation equal to 0. So I'm going to start by adding 8x and subtracting 4 from both sides. So that means that this could be written as 2x squared plus 8x, and be really careful here. And then we get minus 4 equals 0. And then we go and look at the coefficient of x squared, which is a, so a equals 2. B is the coefficient of x, so it's positive 8 for this example. And c is the constant term, so it's minus 4. Then we write out our formula, which says the discriminant is b squared minus 4ac. And now we just need to substitute our values in. So we get the discriminant is equal to b squared, so 8 squared, minus 4 times a, which is 2, times c, which is minus 4. So therefore the discriminant's value is going to be 64, and this is going to give 4 times 2 times 4 is going to be 32, and the two negatives make it positive, so we have plus 32. So therefore the discriminant's value is going to equal 64 plus 32 is 96. So as the discriminant's value is greater than 0, that tells us that we get two real solutions. And that is what the question was asking us to find. How many solutions does that equation have? However, we're going to explore it in a little bit more detail and determine the nature of their solutions. So that is whether they're rational or irrational. So in this case, because the discriminant is not a perfect square, so that is 96 doesn't have a square root that's a nice integer value or rational value, that means that the solutions are, for this case, irrational. And just to explore more by what we mean by irrational, I'll write down the solutions you'd get if you solved this on a calculator or did it by hand. So you'd have x is equal to, and it's going to be 2 minus the square root of 6, or x is equal to 2 plus the square root of 6. And you can see that both of those answers have a surd in there that can't be simplified out. So that makes these solutions irrational, which is what we discovered based on the discriminant's value not being a perfect square. So after this video, you should be able to recall that a quadratic equation must be in the form ax squared plus bx plus c equals 0 to apply the discriminant. You should be able to then use the discriminant to determine the number of real solutions for a quadratic equation. And you should also be able to use the discriminant to determine if the solutions are rational or irrational. And that's what we might call the nature of the solutions.